尊敬的各位专家、各位同仁，大家上午好，欢迎来到竹纤维产业的绿色。
Distinguished experts, ladies and gentlemen, good morning. Welcome to the Green and Sustainable Development and Bamboo Fiber Industry. I'm Chen Haitao from ICBR. It is a great pleasure for me to exchange ideas with all of you. This session will demonstrate the new research and development outcomes in recent years, and we will discuss the development of the industry. We hope to improve the quality of bamboo fiber and extend its application, and finally implement the bamboo as a substitute for plastic initiative. We have invited the entrepreneurs and scholars to present on this session, and the last speaker will be Mr. Li Minghong. And in this session, and you could ask questions in the chat box, and we will answer you by pointing one answer. And this session is organized by ICBR with the great support from our partners. Bamboo fiber, including the continuous and single fiber, and the pulp fiber is the main application form. Next, I will introduce the first speaker of today, Mr. Fang Guigan, the professor of Institute of Chemical Industry of Forest Products, CAF, and he is the academician of the Chinese Academy of Forest Science, and he has been working in pulping methodology and technology, in clean pulping, and the waste disposal. He has made great progresses in the research. And next, let's welcome Mr. Fang to make his presentation. Mr. Fang, please share your screen. Thank you. Dear colleagues, experts, ladies and gentlemen, good morning. And I'm Shen Huizhong from the Institute of Chemical Industry of Forest Products, CAF. I will make a presentation on behalf of Fang Guigan, and today we will review the bamboo pumping and paper making in China. My presentation consists of 5 parts: the global bamboo pulp and paper production, bamboo pulp and paper products, pulping process technologies, and the future outlook. And in the 5th part, I will provide our recommendations. First, before the introduction of bamboo pulp production, we need to learn the current situation in the world. In 2020, the total production is 18.9 million tons. And the wood pulp is about 11.23 metric tons. So we can see actually the average annual growth rate is 1.9%. But the outcome of non-wood pulp is relatively slow. Next, we are going to introduce the production in the world. Paper making was invented by Tai Lun in the bamboo pulp used for paper making can be dated back to the 17th century. And the production in India and Southeast Asia and China differentiated from each other very much. And the second part, I would like to talk about the bamboo pulp and paper products, including the bleached and non-bleached one. And usually pulp is used for paper making. And so the bleached and non-bleached pulp are made from bamboo. The Chinese paper making society once applied for the collective trademark for the bamboo pulp paper. Next, I will focus on the types of bamboo products, including the printing and writing papers. Use print, wood-containing printing papers, wood-free printing papers, coated printing papers, office papers, and writing papers. Bamboo pulp can be used for household papers, including toilet paper, kitchen paper, packaging paper, and the top class paper, just like the paper box on the bottom. Now let's touch upon the pulping process and technology. As we know, actually, the chemical and mechanical and semi-chemical methods can be used. And first, we need to understand the structure of the fiber. Bamboo is a kind of a material high in fiber length. Its average strength is about 2 millimeters, and the average width is 2 to 20 millimeters. And the wall is only 10 to 15 micrometer. And actually, the very good strength and width ratio makes it a very good material. And its cellulose content is between 40 to 50%, and the hemicellulose content is between 17 to 23%, compared with timber. And the ash and pentose content are relatively higher, and the pulping process and technology makes it suitable for the chemical pulping. In 1990s, we introduced the Havana continuous cooking system with the production of 300 tons per day. That is to say 100,000 tons per year. And actually, the process and technology is mainly the sulfur method, but we need to consider the ash removal in the process. Previously, we usually applied single stage and two stage bleaching, and the rate can reach 75 to 85%. But nowadays, single stage and two stage bleaching are used. Currently, we often use the ECM. The ECF can realize higher brightness and better quality. Actually, it is an ideal solution for the quality bamboo paper production. And also the chemi-mechanical pulping is also applicable. The bleaching performance is relatively poor in contrast with timber, but with two-stage bleaching method, 10% of hydrogen hyperoxide can be removed, but the bamboo chemi-mechanical pulp bleached with 3 to 5% hydrogen peroxide is relatively acceptable, and we could produce quality and strong craft paper.
的半化学浆的制浆工艺，如今也在重新开始使用。它是一种
we restarted the application of semi-chemical pulping because it is suitable for the packaging paper production. At least 3 semi-chemical bamboo pulps production are under construction in China. And then the trend and the future outlook of bamboo pulp. Actually, there are advantages and disadvantages of bamboo pulp in contrast with wood production. And the handling lead to higher fiber cost, accounting for 60% of the total production cost. The bamboo pulp is difficult in chemical penetration during cooking, and the bleaching loss is higher compared with wood pulp. And the cover reversion it can easily happen. But there are disadvantages in contrast with timber pulp. At the same time, and the natural color is good, the air permeability is good, it is soft and natural in color, and food packaging paper is better in air and oxygen performance. The bamboo pulp is a good material for calligraphy paper and painting paper. Another advantage of bamboo pulp is that it is especially suitable for the high-grade dissolved pulp. And the eucalyptus, the fast-growing timber species, is not as good as bamboo in terms of pulp yield, energy consumption, degree of polymerization, and fiber length. So the bamboo pulp as the raw material of dissolved pulp still has a lot of advantages. In the first decade of this century, the bamboo pulp production in textile industry reached 600,000 tons per year. And then the future development trends of bamboo pulp. FAO data shows that bamboo pulp is where the bamboo pulp is not separately calculated, and it is calculated into the non-wood pulp production. Though the production kept decreasing in recent years, but it still accounted for 50% of the non-wood pulp production in Zhejiang. And the FAO statistics show that the main producer countries include China, India, and Thailand. So these are the main statistics from the Chinese paper-making society. And actually, the production keeps increasing in recent years. From 2001 to 2021, the growth reached 510,000 tons. According to the state plan, the bamboo pulp production will reach 5 million tons, which double in number, in energy saving, in the realization of SDG targets, and the prospect of bamboo pulp is promising?
First of all, we see the potential resources to resolve the insufficient supply for the palm fiber in Asian countries. Second, for the that is for new environmental friendly pumping technology need to continue to develop. That those equipments is actually we imported from outside. And as for the moment, we need to develop our own in future to give a full play on this fiber. And in the meantime, we need to have the utilizations of the biomass and make those the bamboo resources as or the products and provide the efficient and the profit for this industry. Last but not least, thank you for your attention. Thank you. Thanks for the excellent reporting. For this reporting, talk about for this technology of the bamboo pump production, and also give the alphas the fibers with the advantages to provide for the advanced the pulp, and which kind of products can be developed under this circumstance. So we're gonna invite our second presenter from Mr. Li Zhenfeng from CTBU. He's also the head of this Druma Institute from Bamboo and Institute, and get the award from the National Science and Technology Progress. And his topic is bamboo pulp fiber and its prospect. Welcome. Distinguished guest, good morning.
Good
morning. I'm from the CTBU. My name is Li Zhenfeng. I'm very glad to participate for this the BARC 2022, and I will give you some the share on the bamboo pump and for the development and its prospect, and for the clothing and then travel and the housing, and that is the necessary points for people's living hand. So that is actually bring us for this the needs for this clothing, and for the bamboo as the raw materials is actually and bring us for more the clothing and choices. So for bamboo, bring us our more unique Chinese character to our daily life. For the bamboo, it's actually softer than the cotton, and it's actually for the tian bamboo, we call it. For the tian bamboo fiber, choose the cyanocalamus and the thinness and the witness and the raw materials made with the patent technology. Finished products with soft and skin friendly and greater moisture and breathable, natural and degradations, and really being favored by the consumers. So actually, bamboo viscose is very original from China, and that really help us and to reduce the carbon emission, and also for the energy saving. We actually get the 36 patents and got the 23 award for this technology progress. And we achieved 2014 for the second award in the National Science and Technology Progress. And that really helped us for the comprehensive energy consumption down, and also for the water consumption down. For the TM bun cell fiber has the same molecular structure with ordinary viscose fiber, but it is significantly different. There is the ordinary fiber, we call it viscose fiber, which is from the like wood or cotton. You see the picture on the left, that is for the pig. On the right, that is the bamboo viscose. And you see the structure is different. Bamboo is more kind of like a network perspective. For the bamboo viscose, with the inhabitation rate for the bacteria, and including those inhibition for the colobacillus, and also for the staphylococcus and aureus, and also the candida, the albicans. So, and it's easy to decompress by the microorganism in soil and water, no harm to the natural environment. And also for this natures is the main contents is for the fiber and also water. And also the products for this from the bamboo viscose is excellent discharge, and the highly temperature will not soften and melt, and with a very vivid bright color, which can reduce the energy consumption during the dyeing. And during the burning is on the sticky on your skin. So for the bamboo viscose can replace the photos in the ordinary viscose and can apply it in the textile industry. We have the more healthier products on the bedding products, and also towel or underwear, and also socks. In the meantime, applied for those the tissues or some the working clothes. So bamboo resources actually is the big supply for this the bamboo viscose. We have over 45 million hectares bamboo forest and global. And also for the bamboo is fast growing plants, do not apply the cultivated land, and the strong vitality of 2 to 3 years can be harvested and can grow once time planting and sustainable achieving. And for those we said we have a big background with for the environmental protection policies, and which is for this carbon captures and sink capacity is the 1.72 times than all. And compared to the same the areas in the woods, it can produce more the oxygens, and with for the foreign the bamboo forest is really a natural oxygen source. And also for the bamboo is a symbol of the oriental beauty, is also always the green seasons, which symbolized for those literatures, and to represent the upright and the high characters for the culture. And for this bamboo viscose opened a new era of structural adjustment of chemical fiber or raw material for Chinese fiber production and processing enterprises. and also to increase the farmers' income of remote mountain areas. So we saved the land, and that is provided over 500,000 people for the food. And for the Bamboo Union, so CTBU, and in order to better develop the bamboo, in 2005, where Jilin Chemical Fiber lead 24 textile enterprises, and to form this CTBU to open a very new era for the bamboo industry. For the Jilin chemical fibers is account 31% for the global share for the bamboo fiber production. And for the fiber, the bamboo fibers account 90% of total production. And that is for the carbon fiber account 34% of total global share. That is for the Jilin Chemical Fiber Group. And they actually achieved lots of awards from the national, with the 246 members and 18 overseas offices. And the Bamboo Union has formed and participate for the France for the exhibition shows, and also with the 44 the platform R&D platforms and 200 industry lanes, and to leading the 5 industry regulation standardizations, and also to pass for this OEKU tax certification, OSC certification, FSC certifications, and is really provide the coverage and also the leading role in this industry. And for the Tian bamboo cell fiber has highly consistent with the United Nations concept of sustainability, and also with the excellent products combined with the green concept for the society. For the bamboo, the fiber future, and for this CATU, and also account for the 2022 Team Bibles, and became one of the raw materials in the activity for the 100th anniversary Pure Gardens, the celebration campaigns. And because it's eco-friendly, biodegradation, and no harmful for the environmental, and we will continue be the contributors for the carbon neutrality and to guard the planet. And thank you for your attention. Thanks, Mr. Li, for your presentation. And Mr. Li gave us for this bamboo pulp fiber and its products, and also used the bamboo replaced the cotton, plastic, etc. If you have any interest, you can leave your review or comments on or the chat box. And for those carbon fiber can separate for those textile and non-textile the fibers. So what kind of the textile products came from the the fiber? We're gonna have Ms. Li Minan to share with us on this regarding. Ms. Li's company is undertake the Guangdong province and the national science and technology products with decades and R&D research, they have the series, the award from the provincial and the ministry level, the products.
Distinguished experts, dear colleagues, good afternoon, good morning. I'm from Guangdong Yinan Material Technology Corporation Limited. And thank you, INBAR, for providing such a good platform. I'm very happy to share with you the process and product development methodology. We are a technology-driven, innovative enterprise. We advocate the bamboo as the raw material, and we make full use of bamboo. And in our company, bamboo is used as the main raw material in the textile industry. And now I would like to focus on the product development. Next, I will share with you my presentation, which consists of 4 parts. First is about the bamboo fiber. Second is the processing of bamboo fiber. Third, fine spinning technology of bamboo fiber. Product development of bamboo fiber. Bamboo fiber is different from the other materials in anti-ultraviolet, the antibacterial, moisture permeability, the negative ion oxygen production, etc. It is different from the bamboo viscose fiber. On the market, usually the bamboo fiber is a material after the high temperature carbonization. Its chemical elements are inactivated. These are the ordinary bamboo fiber, but the ecological bamboo fiber is ecologically processed, and it adopted the technology processing method in order to maintain the active antibacterial factors. Through desugar, degumming, delignification technology, the bamboo fibers are sorted and processed. The extracting process is first started with the bamboo from Wuyi Mountain. And then the bamboo will be peeled to remove the parts of the non-fiber part. And then it is degummed to prevent mildew. And then the material is desugared to prevent pests. Finally, it is sorted in order to meet the different requirements for different grades. the bamboo timber for textile purpose or non-textile application. So I will not elaborate on everything. I mean the data, and you could read my presentation by yourself. The spinning process for which I will focus on the difficulties and skills. Bamboo fiber spinning in our factory mainly is realized by our own equipment and technology. So I think in this chart, you could get some information. The bamboo fiber spinning is difficult in the following aspects. And actually, the optimal process adjustment by the disc picker could realize 7 to 10% of the residue rate. Which greatly improve the quality of the finished products. And the cutting machine could be set with the production quantity. The sealing machine can realize 380 watts per minute. And so actually the angle of the knife could reach 90 degrees. Adjustment of the drawing distance is optimized in order to realize the best tensile strength. And the temperature is between 25 to 32 degrees, and the humidity is about 60 to 70%. And this is the best condition. And then the humidity of bamboo fiber should be controlled around 85%. And the bamboo fiber development and application can be used for different textiles, for bedding, clothing, socks, towels, mattress, etc. So the application is really wide. It can be used for the mattress accessories, future elements, latex, etc. And these are the examples of some applications. So this is the future of bamboo fiber. So in this table, you could see the parameter of the finished products. These are some patents, test papers, and certificates of our company. The bamboo fiber is a precious treasure from the nature, and its application is extensive. The textile industry until today has shifted to differentiated chemical fiber to the refined processing of natural fiber in order to realize the sustainable development and optimize the utilization of natural resources. And the innovation in the textile industry has become the future trend in order to realize an environmental friendly industry. So this is my presentation. We are looking forward to working with the research institutions, universities, peer companies, and we want to contribute to the double carbon objectives. Thank you, Mr. Lee. He has introduced the properties of bamboo fiber and different types of the fibers. And I know that the fine production of certain textiles is possible, and your technology is already commercialized, and the fiber products used for the fillers of some daily products is an active experiment. If you are interested in their research and development, please leave your message in the chat box. And through molding, we could produce the disposable packaging materials in order to replace the plastic products. And this is one of the measures of the bamboo as a substitute for plastic initiative. And next, we are going to invite Mr. Wang Jianzhong, the board chairman of Chongqing Ruizhu Plant Fiber Products Corporation Limited. And he is going to share with us the latest technology in their company. Has been in this field for 3 decades. And his company has developed the environment-friendly technology to produce the disposable milk box, etc. Mr. Wang, the floor is yours. Distinguished guests, ladies and gentlemen, good morning. I'm Wang Jianzhong from the Chongqing Ruizhu Plant Fiber Products Corporation Limited, based in the Three Gorges area. And today I would like to introduce the technology and product application of the bamboo fiber molding. Firstly, I would like to tell you something about the background and significance of the program and the harms of the disposable plastic products, plastic containers. In these pictures, you could see the plastic products discarded in the environment. According to The Guardian, 1 million plastic bottles were sold out per minute in the world. And every year, that is about 500 billion. And the picture in the center is from a media report from CCTV. So these are the meal boxes consumed by us every year. According to the investigation, a large amount of the plastic containers are not recycled. On the contrary, they persistent in the environment or they are flushed into the sea. So we need to reduce the plastic products and replace the disposable plastic containers. To address the problems currently, we have developed the degradable plastic, paper, and the other packaging materials.
The degradations, the technologies can adding some starch from the raw materials. The advantages is with the economic costs, but we cannot solve the problem of the plastic. We only just solved or visual pollution, not solved the chemical pollution. So there's still the issues unfinished. In this regarding, we see for the paper replace the plastic, we use the wood or the rod of the plants, and that is we can have some advantages with the can look nice and easy to recollection. But when put the hot water or oil food, there may some poison the contents out. And also supporting strength is not enough. Thirdly is for the biodegradation technology, use the starch. The starch as the raw materials, adding some little fibers. The products, the advantages is degradable, can be recycled with a low the pollution to the environment. But the disadvantages is for lacking of the resilience, and also for the corns and the potato, and that is being banned by the FAO. So regarding this, we have some research and developed our bamboo fiber containers for the bamboo fibers with a lot of advantages. First of all, for the bamboo grow very fast and not harmed to the ecosystem and can be recycled. Second, for the bamboos, the carbon, the chips, and can be achieved in a higher ratio. And for 1 kilos of the bamboo forest can bring the more carbon chips than the average of compared to the other materials. So only for the bamboo forest can bring us 25 the cubic meters the resources. And for the bamboo's fiber with a strong resilience and with natural, and also from our analysis and research, we developed based on the bamboo as raw materials and used this forming technology and to develop this fiber, the bamboo fiber products. With our products and being out, we passed all the testing and the certification. Because the bamboo with a sufficient supply, I think that can replace the other materials, and also to realize the bamboo materials sustainability. And fourth, for we got the in the induction from the President Xi for this the environmental protection purpose. So we can use this as the substitute to the others and can solve for some the resources the scarces, and to promote the bamboo the industry going forward. So now I want to give you a briefing on the bamboo fibers, the containers, their technologies. For all countries, in 2020 from NDRCs, we introduced the policies from the limits and to ban on the plastic gradually, so we can stop using those ones-off the plastic containers, which cannot be degraded, like those drinking cups or some other super thin containers is less than 0.1 to 5. And this kind of products. So for degradable products, they include DED, CDH, EVC, and PET contents, which is the very first time from our ministries and other departments to give the guidance on the ban to those products. So from this limits to ban plastic, and also to make a R&D based on the fully utilization on bamboo. Through our testing, we have this the 3 kind of the technology scheme for the bamboo fiber containers. So one is for to got the reference for the paper making, the principles. Use the additives from the pumping and also for the cold pressing and the hot pressing, and to promote this mold of the containers for food. Second is use the bamboo powder and dry high pressing forms, and for this is used the carbons to shrinking to the tiny fiber or granular, and adding some friendly the environment friendly additive, and to make the mixing and then make the molding. And thirdly, and used for the bamboo chips and for the fibers, and for the cutting and grinding, and use the gas, the explosion, and to separate the fiber. And that to help us with the very green and also environmental friendly is the protection technologies. For this steam explosion process, and that is help us to contribute the third technique for this carbon fiber containers. For this carbon fiber processing progress, we developed the principles from the other materials. We have the slicing the bamboo, and also grinding, and also steam explosions, and to make it to bamboo fibers. And for the INBAR, and have this guidance on this the cases through or lots of the testing experiences. So eventually we formed this environmental friendly products. For this carbon fiber molding container technology, we made lots of the testing. At the very beginning, we use a vacuum absorption the technique. Then we try to those pulping the forming, and then use the injecting pulp for the form. We walk through the up and downs for this R&D research. And for the drying technologies, we use the different kind of the one is for this the electrothermal drying technologies is clean and environmental friendly, but with a high energy consumption. Then we borrowed the microwave drying technology with good result. However, this whole process is rather long, and with a larger footprint. In the meantime, we tried steam and or thermal, the induct the oil media drying technology. With the different kind of the drying technology, we conduct some reference. And thirdly, for the applications for those fiber molding the containers, we can apply it in aviation, and also for the high-speed railway or Western food or food delivery, etc., etc. Also can use in the rural, like for some the chemicals, the containers. And with all those applications, the scenarios, and we can deliver it to those the results area, outdoor sports, the venues. During or applying for these products, so we should pay attention to on our technologies to handle like very super high temperatures or low. So for example, minus 50 degrees Celsius, this kind of scenario. For the medical purpose, we also have some applications. For example, in the hospital, during the operations for those containers, for those the patients using their urine, etc. And in rural, in the farmers, since the scenario, they can to cultivate the seeds when they're used the new sports. They can use this container, the bamboo container. We can recycle those cups for those sports and to bring back, or they can just degrade it in the soil, so that we can form the whole the production chain. Both I would like to share with you or goal for future development. So we will build the bamboo fiber environmental products and platform, and to build this most the characteristics, the bamboo fiber like the container for food, for the healthcare, etc., etc. And in terms of regions, we will based on the region construction, and we have the unified 8 in one to speed up our development and speed up our listing on the capital markets. So I would like to call on the stakeholders who interested in this environment-friendly containers and to talk to us. Thank you.
Thank you, Mr. Wang. Based on the bamboo as a substitute for plastic, he introduced the molding technology, drying method, and product application of bamboo fiber. Currently, their products are sold to the whole world. If you are interested in their technology and products, please leave your message in the chat box. And the bamboo pulp is a highly pure material. It can be used to produce the cellulose derivatives. And next, we are going to invite Ms. Li Xingxing, the Associate Professor of Gannan Normal University. And, okay, Dr. Li, in recent years, mainly focuses on the fine quality pulp research, green bamboo fiber, and nanometer fiber research and the institute. And please share your screen, Dr. Li. Distinguished experts, entrepreneurs, and audience online. Good morning. I feel really honored to present our works, and I would like to focus on the development and application of green bamboo fiber materials. I'm from the Engineering Research Center of Bamboo Advanced Materials and Conversion of Jiangxi Province, Gannan Normal University. And first, I would like to introduce Gannan Normal University, based in Ganzhou. It is located among the Hunan, Jiangxi, Fujian, and Guangdong provinces. It is a red city, historic city, orange town, and furniture city, and also it is a rare earth kingdom. Gannan Normal University has a history of 50 years, and it serves the Soviet area, and the Orange Engineering Research Center mainly serves the orange industry, and also there is a Soviet region history museum, and there is a National Industrial Design Center, and there are 3 national research centers and 21 provincial research centers in this place. And the Engineering Research Center of Bamboo Advanced Materials and Conversion of Jiangxi Province was established in 2009. Actually, the plastic and the microplastic pollution is concerned by the whole world. Actually, a large quantity of plastic pollutants are floating on the sea or buried underground. After degradation, the plastics have been converted into the microplastic and transferred to the food on the dining table. And currently, the microplastic factors can be found in wheat, salt, vegetables, or even the embryo of the embryos. And so the microplastic pollution is a new environmental problem. As we know, the fossil fuel, as including some rubber and the molecule products, result in this greenhouse gas emission. But bamboo and wood products, for example, in paper making, and could sequester the CO2, and some fibers can be used to replace the chemical fibers. And actually, the green fibers are degradable so that it can save energy and reduce the environment footprint. And the bamboo as a substitute for plastic initiative can be realized by using the green and environmental friendly fibers. And China is a bamboo kingdom of the world. And there are about 22 million hectares in China's bamboo forest area, accounting for 29% of the world's total. And Jiangxi is redundant in bamboo resources, accounting for 16% of the nation's total. And currently, the bamboo industry mainly focuses on the traditional bamboo products, which is low in added value and low in economic benefit. And the total bamboo industry production is 321 billion RMB, and Jiangxi province is about 40 billion yuan. And we emphasize the use of bamboo fiber. On the 20th CPC National Congress, President Xi Jinping emphasized the green is gold concept, and also he proposed the bamboo as a substitute for plastic initiative in 2022. Last year, an FGA, together with 10 ministries, jointly published the opinions on promoting the development of bamboo industry. And Jiangxi provincial government and Ganzhou municipal government in 2021 and 2022 respectively published the opinions on promoting the quality development of bamboo industry. Actually, the initiative provides a green solution for plastic ban, and currently plastic products increased by 300%. And the bamboo substitutes could provide a very good solution for bamboo to substitute plastics. Currently, we are developing the bamboo fiber, bamboo packaging materials, and films are also very good substitutes and alternatives for plastics. Currently, we have 30 members in our team, including doctors majoring in pulp and paper making, polymer processing, and textile industry. And we have applied for more than 20 patents. And also, we obtained the total R&D fund of over 15 million RMB in polymer processing and textile and paper making fields. We have recruited the doctors, PhD doctors for the research and development. And actually, the active carbon can be used in the bamboo, will be transferred through the paper making, fiber production, textile production, and the film production, etc. And finally, with the green technology and environment-friendly technology, we could produce different bamboo-based products. And also, in the future, we will develop more products to provide good solutions. And this is the R&D center, which covers about 2,000 square meters. Our lab has a continuous visually monitoring system. And also we have a pilot center and a film and long fiber line are under construction. We hope we could gradually improve our facilities and infrastructure. And next, I'm going to introduce the products and applications, fiber dissolved pulp and its byproducts, and actually effective separation and utilization of bamboo fibrils and parenchyma cells. jointly improve the bamboo pulp quality and pulping yield, our lab realized the technology. After that, we could use them to produce some byproducts, and we maintain a certain amount of their parenchyma cells, which can be negligible. So actually, it can reduce the medicine consumption and could improve the efficiency by 5 to 10%. And by-cell high yield and freeze and thaw-assisted approach to fabricate bamboo-derived hollow lignocellulose microcapsules for controlled drug release. And actually, we could improve the added value and the efficiency after drying and processing. And the structure, the porous structure can be realized. And compared with the ordinary products, actually, in drug use, the release effect could be improved by 50%. And then the efficient removal, we could make it into an active carbon-rich product. So the bamboo can be delignified for paper making, and then the carbonizing could realize the high absorption capacity, and that is the contribution of the parenchyma cells. And the second product of our lab is the bamboo cellulose filaments. This product has been experimented on the pilot equipment, and this textile is green, soft, moisture absorptive, high gloss, and antibacterial, and can be used for suit production. Our experiment shows the section of the fiber compared with the other types of fibers. So we can see actually the dense circular cross section and the color fastness are superior. And also we have conducted the antibacterial test, and the inhibition rate of Escherichia coli, E. coli, and mold reached 90% and 50% respectively. And the third product is a bamboo cellulose film. It is transparent and strong enough. In our lab, we developed a set of pilot machinery, and the strengths horizontally and longitudinally could meet our requirement. And the material is green, degradable, and environment friendly. And also it is antibacterial and anti-static. And around 200 days, it can be degraded in the soil. So this product can be used for food, medicine packaging, anti-static packaging, express tape, and agriculture films. And usually the stability and also the phosphorus recycling are the main difficulties. Currently, we have made some technological breakthroughs. 80% of our products can be fully degraded. And Currently, we are trying to optimize this technology. Hopefully, at the beginning of next year, the breakthroughs can be made. And the first product is the bamboo cellulose additives.
This kind of the fine cellulose, and that is a very good the auxiliaries and additive for the bamboo cellulose. Thirdly, for the nano cellulose, that is a very hot pot in the industry. We also have some the dairy fibers, or some the cosmetics, and also for the lightweight vehicles. And we also have this one of the line to do the R&D. So for acknowledgement, I would like to give my gratitude for our provincial government and for other stakeholders, and also Ganzhou City, and also for the National Natural Science Technology Fund, and for all the supporting organizations. And I would like to hear your feedbacks, and also any experts and entrepreneurs. I would like to talk to you if you're interested. Thank you. Thanks, Dr. Lee, for your presentation. For Ms. Lee, and gave us for this introduction on this the fibers in the dissolved pulp, and also for the products, especially for those the cellulose the applications and high value applications, and also provide a solution for a substitute for plastic. And through the research and achieved some results. So we expect your feedbacks. So we see it for these fibers include for the fiber, textile, and a non-textile fiber industry. And a non-textile used for the pipe or transportation, and for some compound the products. I would like to invite Dr. Li Mingpeng to share with us, and for his topic for this the research on development of bamboo fiber composites, and that's his area. And he leading for the research on the multiple projects on the national level, achieved for the third the award on the innovation and entrepreneurs in the competitions. And now welcome Dr. Lee.
Thank you, Professor Chen Haitao, the chairman of the conference, for your introduction. It is a great honor for me to be here to share with you my research on bamboo fiber composite research and development. I will introduce my research from 5 aspects. The first is the research background. From the Paris Agreement, the United Nations Climate Conference to China's 30-60 dual carbon policy, all the measures show that with the change of development made at home and abroad, the composite materials are gradually developing to green ecological plant fiber reinforced composite materials. From 1960 to 2021, the global composites market is expanding year by year. Last year, the composites yield in Asia was the largest, and China was in particular. At present, glass fiber, carbon fiber, chemical fiber are used in reinforcement in many fiber composites. Glass fiber accounts for 90%. However, these fibers have the problems of raw material shortage, high processing energy consumption, and difficult to degrade products. So it is inevitable for plant fiber instead of glass fiber to produce green lightweight composite materials. Currently, plant fiber composites are mainly used in sports and leisure, such as table tennis paddles, guitar pedals, and snowboards. Transportation, automobiles, subway, industry, wind turbine, boats, and other applications. Bamboo fiber, as the reinforcement, has three outstanding advantages. The first is abundant resource. The world's bamboo resource are more than 70 genera and 1,642 species, with an area of more than 30 million hectares. China has 39 genera and 837 species, with an area of 6.41 million hectares, which is now among the world's highest. The second is lightweight and high strength. The tension strength and the roughness of bamboo fiber can reach the level of glass fiber, which is expected to partially replace glass fiber in the application and composite materials. Last but not least, green and low carbon. Bamboo fiber composites can be used in automotive interiors, wind turbine boats, decorative wall panels, and mobile houses. In the second part, the preparation and the properties of bamboo fiber will be introduced. Bamboo fiber is the main factor reflecting the physical and the mechanical properties of bamboo. It can be divided into bamboo single fiber, bamboo bond fiber, and a continuous bamboo fiber. Single bamboo fibers can be produced by chemical dissociation, which have advantages: single cell wall, small lumen, smooth inner wall, and the rough circular cross section with a small hollow structure. Compared with other plant fibers, bamboo single fiber has a better mechanical tension properties. Bamboo bond fiber can be divided into textile bamboo fiber and non-textile bamboo fiber, according to the Chinese national standard bamboo fiber. Bamboo fiber is mainly outputted by mechanical, chemical, and biological methods. There are obvious differences among the properties of bamboo fibers prepared by different processes. Textile bamboo fiber can be divided into cotton type and hemp type. Non-textile bamboo fiber can be divided in 4 categories. The related physical and chemical indexes are shown in the table. Continuous bamboo fiber are processed through a series of equipment. The bundle fiber has advantages of controllable failures, orientation, straightening, and good ductility. The continuous bamboo fiber with a controllable strength and fairness is made from bundle fiber by twisting wind. Compared with flexible, the specific strength of continuous bamboo fiber is about 15%, and the elongation at break is about 50%, which is suitable for reinforced resin composite materials. So far, there are three key scientific problems in the development of bamboo fiber composites: the poor interface compatibility between bamboo fiber and the polymer, the pole of bamboo fiber, its composite, and the holographic characteristics of bamboo fiber. About interfacial modification, it mainly consists of nano consignment carbonate modification technology. The addition of competitor and competing agent, the properties of bamboo fiber composites can be improved 10 to 50% through interfacial modification. There are three kinds of poles in bamboo fiber composites. That is, natural poles, process poles, and interface poles. The extensions of poles will affect the properties of the composite. Meanwhile, in order to develop the interfacial competitor, holography is also another problem to be solved for the bamboo fiber composite. The tested starch bamboo fiber composite has the hygroscopic characteristics of multi-molecular layer 2, which is suitable for DAB model. Next, bamboo fiber composite materials and products. First of all, the major manufacturing technology, which includes height pressing molding, extrusion molding, injection molding, various deposition molding, vacuum resin molding, and welding molding process. Typical composite of head press molding is bamboo bonded fiber, laminated veneer lumber. The preparation process is shown in figure, including raw bamboo chopping, fabrication, integration, jam layup, and head pressing. Bamboo bonded fiber laminated veneer lumber is mainly used for wall panels of outdoor houses. Typical product of vending molding process is bamboo fiber vending pie fitting. The bamboo fiber fitting equipment is developed independently, mainly including mechanical tensing devices, welding host, control system, and testing equipment for fellow products. Bamboo fiber weighting pipe fetish has the advantages of strong compressive resistances, net weight, smooth inner wall, no friction coefficient, and convenient construction and installation, which is used hygienic transport engineering. For extrusion molding, bamboo fiber composite with core shell structure is produced by bamboo fiber, bamboo dust, bamboo powder, and resin in bamboo popping and paper making. The shell layer mainly includes bamboo fiber, paper pulp, residue, and plastic, while the core layer main includes bamboo residue and plastic, and the products are mainly applied decking and outdoor flooring. Based on well research, bamboo fiber automotive interiors heterotype models parts are developed with the advantages of environment-friendly, lightweight, value-added, and efficiency enhancement.
可以
Moreover,
用于效率的增强。除此以外呢，它比起传统的一些复合材料来说呢，也是可以更适合汽车行业的使用。
parts, the weight of the
和
bamboo
传统的内饰件相比，竹纤维的内衬件呢，重量可以减少17.86%，燃料的消耗呢能够降低0.14升，也就是每100公里的消耗量。除此以外，我们可以简要的看一下这样的一个 FDM 打印式样，所以我们在这里能够看到整个的一个内部结构是非常简单的，所以说呢，这是一个3D 的打印设备。
composites prepared by one-step
它
method.
可以打印一些异形的复合材料，
equipment.
可以用于建筑行业以及日常用品的一些生产。当前，在国家双碳政策的推动下，以及在第2届世界竹藤大会的影响下，绿色竹纤维复合材料的开发和利用将会有助于双碳落地，提高竹纤维应用效率和附加值，不仅能够去缓解气候变化、建造抗灾建筑、消除贫困，
in villages and protecting the environment. The development direction of bamboo fiber composites in the future focused on the following 3 aspects. Realize the integration of raw material, design, and processing, developing new efficiency and low-cost modifiers, and molding manufacturing technology,
能够去开发新型高效低成本
and demand to expand the application yard. Finally, I will introduce my research team, Bamboo Fiber Composite Group. The main research directions of the preparation and performance evaluation of flexible bamboo fibers, the production technology and accompanied equipment, continuous bamboo fibers, and the research development of bamboo fiber composite material. If you are interested in our direction, our group will look forward to working with you. That's all. Thank you all.
好的，感谢李博士的精彩分享。李博士分别介绍了竹纤维制
Thank you,
备、
Doctor, for the wonderful sharing. He introduced the property and performance of bamboo fiber and the problems in development and the application of bamboo fiber. And also he provided the ideas on the research and development of bamboo fiber, as well as application. Today, the 6 presenters have finished their presentation. We still have a few minutes for you to leave your questions in the chat box. Currently, we have received some feedbacks and questions, and I selected some typical ones and I will ask 1 or 2 questions to each speaker. First, question goes to Mr. Fang. The bamboo pulp production will influence the water environment compared with the timber pulp. And are there any prevention measures for the bamboo pulp production? As for the pollutions caused by the production of bamboo pulp, in contrast with the timber pulp, actually the chemical pulping machine could realize the pollution-free production, and the standard and the result can actually reach the standard for the sewage disposal. And actually the primary, secondary, and the third level water treatment are adopted in the production process according to the relevant environmental protection law. And actually the solid wastes, including the fibrous elements, are reused and, for example, used as a film compared with the timber or the wood pulp. And the cooking system may consume more energy. So, and secondly, and what is the second question? I'm sorry. Compared with the wood pulp, and how well is the bamboo pulp in the processing cost? Actually, it is similar to the wood pulp. And the wood pulp manufacturing in the sewage treatment need to add nitrogen, phosphorus, and salt into the process. But actually, the bamboo fiber production is different. They only requires a small sum of the above mentioned elements. So actually, the nitrogen and phosphorus elements in the bamboo pulp provide us with the advantages. And what is the maximum production of bamboo pulp? Is it say chemical pulp or what type of pulp? Up to now, the chemical pulp could realize 250,000 tons, and also above the ISO standard. And the pulp can be used for quality tissue for daily use. Bamboo timber is a kind of active material, and the lignin retention in bleaching is a little bit difficult. Currently, we are doing relevant research and development, but now we could realize the bleaching rate could reach 65% to 70%, and the product lines under construction could realize a production of 100,000 tons. And in some places, they are planning for the more production capacity. And so these are my answers to the two questions. Thank you very much. You provided very specific data. And because of the imported pulp problems, so the bamboo pulp production and demand increased in recent years. And the second go to Mr. Li, and the antibacterial performance is actually endowed by the property or say the characteristics of the pulp itself, and whether you have a branch in Hunan. So these are two questions for you. So the first question is the antibacterial activity is transferred from the raw material, and this is not a kind of say artificial work. If it is added to the finished product, I would say the cost will be much higher by at least 5,000 RMB. So actually, this antibacterial performance is born with the raw material. So this is the first question. And the second question is about the company in Hunan. We originally had a company there, but
湖南益阳还有这么一公司。好的，主
we
持人。
have a branch in Yiyang of Hunan province. So these are my questions. These are my answers. And in the interest of time, I need to speed up. And the third question go to Li Minan. And will the production of bamboo fiber pollute the environment? And do we need water treatment after the production? Bamboo fiber production needs to be addressed, and we built a sewage disposal plant to recycle and reuse the disposed water, and the deposits and the sediments need to be filtered and compressed into the fill or fertilizer, so that we could realize zero pollution to the environment. As for water treatment, because the water in production are repeatedly reused again and again before discharge. In the interest of time, we will stop here. We cannot answer all the questions, but you could contact the speakers after the meeting, or you could contact the organizing committee. And thank you again for the speakers. And we are going to